Assalamualaikum and hi everyone. Today we from Group 1 will present about sedimentology from task 1 until task 4. So we go to introduction part. Sedimentology scientific discipline that is concerned with the physical and chemical properties of sedimentary rocks and the processes involved in their formation, including the transportation, deposition and lithification, transformation to rock of sediments. The objective to much sedimentological research is the interpretation of ancient environmental conditions in sediment source areas and depositional sites. Sedimentologists study the constituents, textures, structures, and fossil content of the deposits laid down in different geographic environments. By this means, it can differentiate between continental, littoral, and marine deposits of the geologic record. So we go to the next part.
Assalamualaikum, my name is Ashura Aishahadana binti Ahmad Ridwan. Today I will present about dropstone in task 1. Dropstone was discovered by scientists in early 1970s, which is its age is 1 billion years old. It can be found in the cold water along brachiopod fossil, also known as ancient seashells in shallow marine depositional environment. Dropstone has been transported on ice from the South Pole. It has various types of dropstone that are originated from another continent found in Langkawi. Based on the video, the shape of dropstone mostly are sub-rounded to angular with high and low sphericity. For example, this structure subangular with medium sphericity of shape. Based on the table, in the early Carboniferous, a robust member of single formation at Langkawi, dropstone can be found at the red mudstone. It was housed by shallow marine sediment that are formed by dropping of glass from iceberg, while for the glaciation cycle of middle Carboniferous of contour member of glaciers, dropstone present in deep marine sediment that are formed by dropping of glass from ice sheet. Based on the figure 3, it shows well-rounded of granite dropstone in the red mudstone of Chepo member which has high sphericity, while for the figure 4, it has subangular of granite dropstone in black shades of contour member that have high sphericity. For the figure 5, it has well-rounded sandstone dropstone of Kenny Hill Formation high sphericity. Lastly, for figure 7, it is have high Carboniferous sandstone of Bukit Raja member have medium sphericity. Next is, based on the figure 6c, it shows lithic arenite sandstone that are characterized from diamantite from the Carboniferous to Permian Kenny Hill Formation, composed of sub-rounded to rounded monocrystalline quartz with some rock fragment and clay matrix. It contains brown to brownish grey iron oxide stain of the quartz vein. It is also have medium maturity with moderately sorted. Based on the description before, the distance of the transport is increased and moderate, which show it come from the river. Next is, based on the figure 6D, it is polycrystalline quartz with cracks and quartz overgrowth in some diamites from the Kenny Hill Formation that are composed of angular to subangular with high sphericity of shape. It has less maturity with decreased and less distance of transport. From here, it shows the source of sediment is from alluvial fan. This is from me. Thank you.
Hi, I'm Fahir Aslam, and next for task 2, we are assigned to summarize the sedimentary logs of section 1 and 2 composite logs, as well as section 3 and section 4. For section 1 and 2, the composite section 1 and 2 record the succession in the sector north of the east-west trending fault, and the record the strata overlying the Sinai limestone. The lowermost is characterized by thin bedded chert and intercalated black mudstone. The unit is then sharply overlain by the Carboniferous Chapor member of the Kubang Pasu Formation. The contact is observed to be faulted. Telaga Jatuh Formation is composed of dark grey to black mudstone, with occasional lighter colored clay concretions. Basal mudstone is then overlain by an approximately 14 meters. The sand-dominated interval comprises of meter-thick medium to fine-grained sandstone lode casts, basal mud-class conglomerate, cross-bedding, and an upward fining vertical pattern. Next is section 3 and section 4. Section 3 is the section logged along the exposed east-west fault plane. The lowermost 18 meters is represented by the Silurian Mempelam limestone, which is characterized by centimeter to decimeter thick beds of grey-colored, fine-grained stylolithic limestone with interbedded thin black shales. For section 4, the lowermost part of the section exposes the Sinai limestone. The unit is composed of tabular bedded, decimeter thick, fine-grained stylolithic limestone with thin shale partings and syneresis cracks. Overlying the Sinai limestone resembles composite section of the Telaga Jatuh Formation, sharply overlies the Sinai limestone. The overlying mud-dominated intervals of the Chapor member in section 4 contains a rich fossil. Next, for B, we are assigned to discuss the sedimentary rocks of the outcrop in the figure at the given timestamp. The outcrop shows the change from the Devonian Sinai limestone to the Carboniferous Telaga Jatuh Formation. The boundary between the two units is a parallel conformity which marks the Devonian Carboniferous boundary. And the Yanging direction is towards the right, where there is a carbonate rock, which is limestone followed by chert and glacial moraines. After that, for C, we need to discuss the sedimentology and depositional environments of the Sinai limestone. The Sinai limestone member displays several characteristics of a deeper water pelagic limestone facies, such as fine-grained, thin-bedded limestone with shale partings and a prevalence of pelagic fossils. It is mostly comprises of pelagic fossils including cephalopods, dicroconarite, tentaculitates, conodonts, and ostracods, with relatively few benthic fossils or trilobites. The depositional environment is thought to be deeper water, maybe on the outer continental shelf or even at the continental edge. The lack of coarser-grained carbonates and extensive bentos rules out shallow to intermediate depths. Lastly, for D, by referring to the figure or the microphotographs of the Sinai limestone sample at the given timestamp, we need to do the classification based on the Folks classification. And there are two. The first one is orthocams, which consists of micrite, and the second one is the allocams, which consists of fossils, oolites, pellets, and interclass. The fossils are biomicrite, orthoconautilate, ostracod, brachiopod, crinoid, bivalves, trilobites, and conodots. For oolites, there are umicrite. For pellets, there are palmicrite. And lastly, for interclass, there are intramicrite.
Hello everyone, my name is Karthikveni Krishnamurthy. So now I would like to explain about task 2 from question E until question G. So first of all, for question E, the question is discuss the lithology and depositional environment of the Telaga Jatuh Formation. Previously, in early Carboniferous chert beds discovered in northwest Peninsular Malaysia, it was thought to be a part of Kumbang Pasus Formation. However, the layers are lithologically different enough to constitute their own stratigraphic unit, which is dubbed to be Telaga Jatuh Formation after Bukit Telaga Jatuh, a hill in the Pokok Senak district of North Kedah that exposes the unit's thickest sequence. At Kampong Warjentik, the thickness is just approximately 10 meter, and the lithology is dominant by regularly alternating flat strata of grey chert and black shale, and the slum structure are quite prevalent there. Radioclinical from the early Carboniferous chert beds, the beds chert was formed in deep water at a period of strong plankton production and is thought to be a continental edge chert from the relative deep seawater. So that is the discussion about lithology and deposition environment of Telaga Jatuh. Thank you. Okay, the next question in task 2 is question F, where discuss the sedimentary process and deposition environment of Cepur Member Kumbang Pasu Formation. Okay, in Cepur Member, it is interbedded mudstone and sandstone dipping towards east. Sharp contact chert overlies the Telaga Jatuh Formation. The mudstone face is comprised of DM to M thick mudstone displaying faint and very grained sandstone to siltstone laminate with streak-stand lenses and also moderate to strong bioturbination. The face is interpreted as representing a combination of quiet water deposition from suspension and occasional distal storm deposition reflected in the thin slit and sand streak and also laminate. The mudstone also can be get cemented, and if it break it, and we can see trace fossils. All this in the marine environment, which is also practical cephal environment. In terms of age, the low part of formation is very rich in fossil like bivalves, corals, and also bacteropod. Kumbang Formation also can be related to Langkawi Formation, which is Singa Formation. Okay, that's all for question F. Thank you. Okay, the final question for task 2 is question G, which is compare the glacial marine deposit in Cepur Member of Kumbang Pasu Formation in Perlis and the Singa Formation in Langkawi Highland. So basically the comparison of this glacial marine, where in Cepur Member of Kumbang Pasu Formation is the oldest glacial marine, while in Singa Formation in Langkawi it is a younger glacial marine. Next, the period of formation of glacial marine in Cepur Member is Carboniferous period, while for Singa Formation glacial marine it formed in the early Permian. And finally, the rock unit that made in Cepur Member Kumbang Pasu glacial marine is sandstone, while in Singa Formation in Langkawi it is made up of mudstone. So that's all from me. Thank you.
Now I will continue with task 3, the location at Sydney Basin without Wilton Formation. For sedimentary structure, the Sydney Basin part of the much larger Sydney Kanda Power Basin is located at New South Wales. So, seeing uplift of the basin in the Triassic up to 600 meter of sediment has been deposited on part of the continental shelf north of Sydney. Significant thickness of sediment up to 80 meter have accumulated in coastal depressions such as Botanic Bay and Lake Macquarie. Most of this unconsolidated material is Cenozoic or Quaternary in age. The Kubelan Plain was probably formed about 80 million years ago, associated with the opening of the Tasman Reef of Eastern Australia, and this distributed old stream pattern and largely resulted in the geography that we see today. At different times during the Renozoic Mohammed condition as that today, resulting in the formation of laterally soil. These laterally are well developed on the Hawkesbury Sandstone, Narrabeen Group, and Vianatama Group. Present day weathering has resulted in a new profile well being developed on this much older fossil soil profile. The rock sequence on the Sydney Basin have undergone only minor faulting and faulting since they first formed. The only large-scale faults are those of the limestone monocline at the eastern foothill of the Blue Mountain and further west the Thomas monocline. With more interesting are large-scale excavation in the Sydney region in recent time, for are becoming more widely recognized, though most appear to have been inactive of at least the last 90 million years within a sub-vertical to vertical joint set space. Subvertical to vertical joint set common within the Hawkesbury Sandstone and prominent along the coastline. So for the next, I will continue about bioturbanization at Wilson Formation, Sydney Basin. Bioturbanization is the reworking of soil and sediment by animal or plant. This in fact includes changing texture of sediment, bioirrigation, and displacement of microorganisms and non-living particles. Review the type setting. Formation Wilton at Australia. So we continue about plant elimination at the same location. Bits that are deposited in even horizontal shear are called plain bits. Are the composite of plant laminate, typically 5 to 20 grain in thickness. Plain bits form a higher flow velocity beyond those capable of forming dune. Also typical of plain bits are curate lamination, lineation, which are furrow and rigid, a few grains in higher that are oriented parallel to flow direction. Laminate though ever in thickness literally. So for the last, curate ripple at the same location. Curate ripple or rip mark are caused by water flowing over loose sediment, which create being formed by moving sediment with the flow. Being formed are linked to flow, velocity, and sediment size, whereas ripples are characteristic of shallow water deposition and can also be caused by wind blowing over the surface.
The Yellowstone the Yellowstone volcanic field from the high continental divide between the North and Middle Rock Mountain. Yellowstone has been shaped by exploration, infiltration, and profound collapse of the ground. Oncalistic lava flow, uplift, and interstic faulting, and the erosion power of flowing water and ice. Three infiltration cycle is included and is site catering for mid-infiltration that excavated impermanent volume of magma from the volcano. Massive polyclastic glycetic current depositing in tuff and the area contain avoided the ejected magma can break complicated to from a crater. We'll start with the bottom area, which is we call as Paleosol briquette.
precursor are in-scale salts that have been incorporated into the geologist record. Salt formed in response to interrogation among the lithosphere, hydrosphere, biosphere, and atmosphere. So, paleosalt interpreted record physical, biological, and chemical information about past condition near Earth's surface. Okay, next move the next level. Asphalt 2. Asphalt 2, from that we can see, and then is this pyroclastic flow move across the landscape that line, and that we call as pyroclastic flow. Pyroclastic flow including the landscape, the bottom of the pyroclastic flow in contact with ground, so it's cooling very quick. There is a big temperature change. Okay, for the third layer, we call as a lithosphere. Lithosphere is a volcanic rock with a pyroclastic texture in which a larger crystal are embracing in a glassy ground mass. Okay. Next, weathered tuff. Weathered tuff is just a rhyolitic, so has a lot of internal folding in it. Can be physical originating gas bubble that are kind of glacier is. Definitely has a fabric to it, or a planar or nearly planar environment here, so it has a lot of layer to it. Or lastly, we call as third layer, we call as a lithosphere. Lithosphere, the top, not all time, but at times if we have a full session, which is not always that case, we might see a little bit more at the lithosphere, that glass layer where the top of the pyroclastic flow cooled in contact with their air. Okay, first rock contact. Okay, rock contact. For the figure, what can you see? I have drawn one line to make a different type of rock. So first, the below of rock, the color of rock look more dark than the top. Okay, rock context. Rock context is a boundary which separates one rock body from others. A context can be formed during its formation by the intrusion of magma, or through faulting or other deformation of rock bed that bring distant rock body into contact. The little bit of bleaching and little discoloration. Okay, second, ground zero. Usually, ground zero where the hot actually intensity hit the ground. And lastly, asphalt 2. Asphalt 2, when interaction started to occur when the ash was just kind of getting out of the vent validating the landscape. This is asphalt up. The predication for the big day compressed flow. First, sediment structure of an individual have a two. First, convoluted joint. Convoluted joint is a geologic structure where set of interested closest space fracture, referred to as the joint, result in the formation of a regular array of pebble primes or comets. Comets join occur in many types of igneous rock and are formed as a rock cool and contrast. Comets join can occur in cooling lava flow and ash flow tuff, as well as in some shallow intrusion. Comet join also occur readily in sediment rock if there have been attached by nearby hot magma. Second or lastly, crag plume. Crag plume is forming in the paleosalt in this action sol horizon. That's all.
Okay guys, after present from task 1 until task 4, we can conclude the sedimentology is a scientific study of the physical and chemical properties of sedimentary rocks, as well as their formation processes such as sediment transport, deposition, and lithification, conversion to rock. The understanding of ancient environmental conditions is sediment source regions and deposition sites is a primary focus of a great deal of sedimentological research to date. That's all from Group 1. Thank you for watching.